Hello and welcome back to decision analysis, and now we are in the final section, section 3 of chapter 7, your fall. So this is a minimal example. So I have listed here a code. So if you really want to make the minimal effort and pass this course, what you should do is do something similar that is done here in the calculations, the example LL for Laiha-Laihian, and you include a code like this, and also you have to make a small report with Word or whatever you use, and include these calculations there, so you will pass the course. Of course, not just copy paste this, but do your own version of what we have here. So this explains Laiha-Laihian's fall, and this is the kind of minimal thing that is required from you, an example. So let's look at this and let's go through this comment block here. So this explains the problem. So we have example underscore LL. So Laiha-Laihian's fall, a minimal M file for assignment your fall. Adding report to these kind of calculations will give you accepted assignment in grade 1. So what's the problem description? So Laiha-Laihian lives with her mother in Laihia and contemplates what to do in the next fall. And Laila considers the following 3 alternatives. So A1, move to Vaasa into a Vaasa flat. A2, commute daily between Vaasa and Laihia and Vaasa. And A3, distance studies from Laihia. And then Laila has decided or thinks that there are 3 scenarios that are relevant to these solutions. And these are related to koala Ebola pandemic. So S1 is that koala Ebola is contained, so there is no pandemic. S2 is that there is pandemic, but the campus is open and teaching is partly distant. And S3, koala epidemic is pandemic, campus is closed and teaching is distant. And the scenarios of these probabilities Laila has somehow estimated. So P0 is the koala Ebola pandemic probability. So P0 is P2 plus P3. So the probability that the koala Ebola is pandemic. Q0 as always is 1 minus P0, and the probabilities are P1 is Q0, so no koala Ebola, and then these campus open or closed are equally probable under the pandemic, so they are P0 over 2 and P0 over 2. Laila will have 2 decision matrices and she uses expected value rule. So what are the decision matrices? So this is a multi-objective decision problem. 2 decision matrices R1, which is monthly expenses, and they are assumed to be something like this. So there is a baseline studying from Laihia. Monthly expenses are 0 because Laila lives with her mother and mother takes care of the expenses. And otherwise, there is if you move to Vaas flat, then you have to rent, and then you have to pay the food, and then if you commute, then you have to pay for the car insurance and gasoline and so on. So again, these numbers, I'm not completely sure that they are reasonable. Let's hope so. Then we have to, this is the monthly expenses. No one wants to maximize expenses. We want to minimize them. So to make this a maximization form, we multiply it by -1. Then the other decision matrix R2. This is the study credit points and the different alternatives, different scenarios. I hope these are reasonable also. So these are the credit points for different scenarios for living in a Vaasa flat, driving to Vaasa and studying from Laihia. Maybe they are reasonable, I don't know. Then we have the sensitivity picture, and we have seen this before many times. We have 2 problems because we have 2 decision matrices. Take a sampling frequency. I've always taken a sampling frequency 500. I've noticed that this is a good compromise. It gives a nice picture and still takes only 3 seconds to calculate. So n equals 500. Then we have P0 samples. linspace from 0 to 1 n values, W samples, linspace from 0 to 1 n samples. So P0 will be the coalable pandemic probabilities, and W samples will be the weight. All these decision rules are combined. Then we set the decision problems constant fields, the fields that don't depend on W or P0. So DP1, D rules expected value, its D matrix is R1. Decision problems 2, decision rules expected value, and its D matrix is R2. So they are same rule, different objectives. Then we calculate the sensitivity matrix. So for I, now I'm not used length P0 samples, but N, it's capital N, it's the same thing. I take P0 and Q0 to be what they are. Then for both decision problems, I put the probabilities to be what they are. So Q0, P002, P002. Always note the quote here. So these are column matrices. Then I solve the decision problems. Then I take V1 to be the D value, so decision result 1, and scale them. Same for V2, so they are D values from the decision result 2, and scale them. And then for J goes 1 to N, I take the weight W, and I take it as W samples at point J. I combine the value functions V1 and V2 with the weight W, and then I take the maximal index of the vector V. So maximal value goes to temporary variable I don't use, index goes to ZJI as always. And then I draw the picture. Now if you want to make a minimal example and don't want to fine-tune anything, then this is very short. You just type Ctrl F, P0 samples, W samples, Z, and that does the picture. So let me actually show how this works with GNU Octave. I start Octave, I go to my working directory, so work, teaching, ORMS 2020, and choose. And this is example.ll, so you can download the file from here and put it into your Octave working directory. But just type it, then it takes some time. It calculates, but not only a few seconds. Sorry, not that window, but this window here. So this is what you get by the standard output to counterpart. So these are the colors. So there are no labels here, so you have to explain which area corresponds to which choice. And then you can see that there are no labels P0 or W here either. And the axis marks are very small because I didn't use it set get current axis font size 24. So this is not such a nice picture as if you fine tune it, but it's not strictly not necessary to fine tune anything. And then you can print this, for example, like save as here, and use here different for GIF, JPG, PDF, whatever, hoping it works, or you can just take a screenshot if you like. So that was a minimal example. Here is sensitivity picture with shown already, and that was all from the assignment Your Fall. See you in next video lecture. Bye.